Yeah, good day, guys. Welcome. Today we shall be looking at physics, and our topic is actually measurements and units. You could recall in our last class what we did was quantities. Today I'm making reference to that very topic because we can't deal with measurements without talking about quantities. So just to give a simple recap, we said quantity simply means any measurable quality that you use in describing matter. They are called quantities or properties, if you like. Today we are looking at length, mass, time being the three major fundamental quantities in physics. How do we talk about length if you cannot measure them? And that's the reason why you must understand the measuring instrument for each of these three important parameters or quantities in physics. Number one, we have the length. And how do we measure length? Basically, length are simply gaps between 2 points. So we use various instruments to measure these gaps. These instruments ranges from the meter rule, follow me, from the meter rule down to calipers. You move down to micrometer screw gauges, screw gauge, as well as the vernier caliper. Follow me as we drive this. When I say, I said meter rule, pardon me, meter rule. So when you want to measure the length, what you need is to get a particular rule called the meter rule, which can come in various forms. It can come as a tape, it can come as a normal wooden ruler, it can come as even a plastic ruler. The major thing here is that you want to get the gap, the length of this gap. When you have a meter rule, it has what we call, every instrument you know have what we call precision. And depending on what kind of length you want to measure, it determines what instrument that could be used. For example, you don't want to measure a curve and bring a straight meter rule. So I'm trying to tell you that we measure gaps based on using instruments based on the curve, the straightness, the thinness, the thickness of what you're trying to measure. Let's say, for instance, I'm to measure from the beginning of this to this end. This is a straight kind of length and it's a bit long. So I can use a meter rule to run this, and I'll measure them in maybe cm. So the unit of measuring this actually could be what? In cm, could be in meters, could even be in kilometers, depending on how long the place what you're trying to measure is. But note this, that in physics, the standard unit for measuring length is meters. That being said, calipers. I'm still talking about length, so don't get it twisted. What is a caliper? Please, to make this very simple, a caliper is not actually a measuring instrument, so to speak. It's actually a device that is used for transferring measurements. So we have two kinds of calipers. We have the internal caliper and the external calipers. They just look like your divider in your mathematical set that you use in picking measurement and transfer it somewhere else. So if you have, say, look at this. Assuming I have a ring like this, a big ring. Now the caliper looks some sort like this. Pardon my drawing, it's looking a bit wacky, but then you just get what I'm trying to say. And then we have it like this. All right, I think I drew it a little bit wacky, like I said. Good. Now this can extend. So this is, if I put this maybe at this outer part and put this here, I can get the diameter of something when I transfer it to a meter rule like that. So that's all about the calipers. The internal is also the same, just the opposite. Then we have the vernier caliper. The vernier caliper is just a special instrument that combines a straight meter rule with the caliper I just described to you. So it's used for measuring the smaller ring. Let's say the ring of your hand, the diameter of knots, and that's what that's all about. Micrometer screw gauge. This is the most sensitive length measuring instrument that can measure the thinnest paper you can think of. So when you want to measure the thickness of a paper, you cannot come and tell me you're using a meter rule. It's not going to be possible because its precision is the thickness is too thin and precision is very high. So it's too low, rather. The smaller you can read, the higher your precision. So the precision of micrometer screw gauge is higher than every other instrument right here. So if you open the page of your paper, if you look at it, you almost think that it's nothing, you cannot measure it. But bring it close to what? A micrometer screw gauge and you'll be shocked that you get that measured. I've just hit a point to tell you that in case you're asking your JAMB exams, what instrument is used to measure the thickness of the paper, please don't say a caliper. Rather, say this. All right. Having talked about length, we move to the next most important quantity in physics, and that is mass. So what is mass? Mass is an intrinsic property of every matter that cannot be changed no matter where you are on the Earth or even outside the Earth. So it means that it does not depend on any other thing. It depends on the material itself that it's been made. So it's a quantity of what the material is made up of. Say for instance, the way you are, your level of your weight is not determined by people around you. It's determined by the things you've eaten. right? I'm just using weight, even though it doesn't look like the best thing to use, but then you understand what I'm trying to say. So that means your brother doesn't determine how heavy you are. You determine that within everything that is inside of you. That being said, we talk about mass being an intrinsic property of any matter that cannot be changed by environmental factors. So we measure our mass using instruments such as, follow me, we have the beam balance, and you can also use the principle of moment. So if you stick around for a long time in this on this channel, rather, you will see a lot of things being described. We'll get back to this as a topic and you understand what this really means when that time comes. But for now, let's stay focused on this. Now, what's the beam balance? A beam balance is actually a balance that's created to measure the mass without factoring in the gravity. So that means even though it's measured upon the earth, because normally when you measure a body and gravity is the weight of the mass of the body with gravity inclusive, that's the weight. So the instrument, a special instrument that is used to measure the mass of a body upon the surface of the earth without gravity interfering is called what? A beam balance. In fact, in chemistry, it's called the chemical balance. Now, this instrument you see here actually utilizes this principle of moment to operate. That being said, when you measure masses, you measure them in what unit? You measure them in kilograms, grams. In some country, you hear things like tons. You can even hear other things, or pounds. But as far as you're concerned in physics, the most important unit, or the SI unit for measuring mass, is nothing else but kilogram. So usually you want to convert almost all of your masses into kilograms before you can be used for calculation. That being clearly stated, I believe you understand what I just said. So when I say the principle of moments, it's clear to everyone who understands moments. And if you don't understand, just follow me. If you have done seesaw before in your life, you know they call this play when you're younger, you go to your playground and somebody sits at the other end, and you are going up and down. That seesaw principle is based on this moment, and that means that if two people have the same weight at two edges, they will balance. So if you know the mass of one person and the stuff balances, you know that that's the mass of the second person. That's the principle by which we operate. So if we are two and we have it, say this way, and here, and this place, normally if this way is heavier, it should come down. And if here is heavier, here should come down. But if they are on the same horizontal level, it means that if you know this value, you automatically know this one. So if here is 10, here is 10, provided they are what? They are balanced. And that's how you measure the mass. I believe that is pretty simple. Now, I've explained what mass is about to you, but something is very, very cogent that I've not said. And let me tell you, I bet you, most guys won't tell you this if you don't go detail. But on this channel, we have L-bends. All right. Earlier, I've made mention of mass and its measurements, but something cogent I must say right now, which is very vital for you as either an SS3 student or a JAMB WAEC, is the fact that mass is often confused with something else called what? Weight. You think mass and weight are equal. You think mass equals weight. Unfortunately, no. Mass is related to weight, but they are not equal. So what is weight? Weight is simply the Earth's gravitational pull over the mass of the body. Therefore, the measuring instruments are also different. We have two major measuring instruments that can be used to measure the weight. First we have here is the spring balance. Spring balance. And the second we have is the lever balance. So note that mass is not equal to weight. Weight puts the Earth's gravitational pull in view, whereas mass is not concerned about that. So the mass of a body on Earth is equal to the mass of the body in the moon. But the weight of a body on Earth is different from the weight of a body in the moon. Reason, the gravitational pull upon the Earth is higher than that of the moon. That's why in the moon, people talk about weightlessness. I just thought to give you that understanding. Like I said, having now realized that mass and weight are not the same, yet they are related. So there's a mathematical formula that is available to connect them. So we have weight is equal to mass times gravitational pull, or let me say weight times acceleration due to what? Gravitational acceleration. Or you call it acceleration due to gravity, which you can really write as what? G. All right, we have gone a little bit far. We had talked about length, mass. Now we are talking about this young guy here, the time. Everything upon the earth happens in time. So we make measurements of events using time. We put events with time. We schedule events with time. So you may not be able to tell me what time is, but it simply means the period between which an event occurs. And just know that in your mind. So how do we measure time? We have two major instruments to measure time, and we call them we have what they call the stop clock and the stopwatch. Of course, there are a lot of things to talk about when it comes to time, but I don't really want to bore you with the story of the sound clock and other things. These are the two major instruments you use now. They are very vital for your class. So we have the stop clock and we have the stopwatch. But notice that time can be measured in what? In year, day, hour. You can even call it week if you like. Of course, minutes and what? Seconds. The most important of all of this is no other but seconds. So you measure time in what? Seconds. As far as this is concerned. So if you know if it's 30 years, convert it to what? Seconds. So how do I convert time from say minutes, hour to seconds? Basically, nobody is going to give you a year, but in case they give you, just use your mind to understand that actually 1 hour is equal to 60 seconds, right? Sorry, 60 minutes, permit me. And at the same time, we have what? 60 minutes is equal to what? 1 minute rather is equal to 60 seconds. So if you're a good math student, somebody is now telling you what will 60 minutes be in second, or what will 1 hour be in second. You just knew that 1 hour is what? 60 minutes. So 1 hour is equal to, convert this 1 hour to minute, becomes what? 1 times 60. Is that true? This 1 hour. Then convert the minute to what? To seconds, becomes what? 1 times 60 times 60. Because this is what? Convert to what? For those that are still getting confused, let me help them by saying 60 times 1 minute. Do we agree? And lastly, we have what? 1 times 60 times, this is now 60 seconds, right? So you have 3,600 seconds is found in what? In 1 hour. So this simply means that in your mind, every time you see 1 hour, as a good student, just know what? 3,600 seconds. This is going to save you $1 million. That being said, the most accurate of these two instruments is the what? Stopwatch. Because you can measure in milli and microseconds. Now that you understand all of this and you know why we now measure quantities, is because without measuring the quantities, we cannot effectively use them to carry out calculations. So put that in your mind, and I'll see you in my other video.